Hello students, hope you are doing well. Today we are going to discuss about another important topic from the colloidal dispersion system, that is kinetic properties of colloids. This is Suryam, Assistant Professor, Department of Pharmaceutics, Vishnu Institute of Pharmaceutical Education and Research, Narsapur. Let us discuss the properties in details. In this class, mainly we are going to discuss about the kinetic properties like Brownian movement, or also known as Brownian motion, settling or sedimentation volume, or also known as Stokes law. Another theory, that is diffusion theory, which is also known as Fick's law. So these are the different concepts where we can discuss in detail about the movement or the motion of the colloidal system. And let us start the topics in detail. So generally this kinetic properties is related to, like, kinetic means a motion of the particle or the movement of the particle. Means the major the concept of this kinetic properties is we need to understand how a particle is going to move around in dispersion medium. So when we are having different phases, dispersion phase and dispersion medium, as we discussed in the earlier classes, so colloidal system will be contains as dispersion phase and dispersion medium. So when we are trying to learn the movement, how a dispersion particle is going to move in dispersion medium, so that to understand that we need to discuss about the kinetic properties. Kinetic properties refers the motion of dispersion phase in dispersion medium of colloidal solution, as we just now discussed about this. The kinetic properties of colloids can be understood by following theories. They are Brownian movement, which is also known as Brownian motion, and this Brownian movement or Brownian motion is also known as zigzag movement, which is also known as drunken walk theory. And the second theory, that is sedimentation volume, also known as Stokes law. And the third theory is diffusion theory, which is also known as Fick's law. We'll discuss about the three different theories in detail. So let us start with the Brownian movement. This Brownian movement is also known as Brownian motion. This Brownian movement or Brownian motion was explained by Robert Brown in the year 1827. Brownian movement is also known as zigzag movement or drunken walk theory. You need to understand this. So why this is known as zigzag movement and why it is also known as drunk and walk theory? Because there is no proper directions in the movement of the dispersion phase during while they are dispersing in the dispersion medium. That is why it is named as zigzag movement or drunken walk theory. So it is very important to remember that the zigzag movement or drunken walk theory, in the exams they may ask you explain about the zigzag movement of the colloidal dispersion particles, or they may ask you like explain about the drunken walk theory. So this will be like indirect questions in your exams. Brownian movement states that the kinetic bombardment of the particles by the molecules of dispersion phase, and it may leads to random movement of particles, is called as Brownian movement or Brownian motion. So the Brownian movement or Brownian motion is explaining the bombardment of the particles by the molecules of dispersion phase, and it may leads to random movement of particle. That means if we have a colloidal solution, as we know, this colloidal solution contains dispersion phase and dispersion medium. So now we need to discuss about the movement of the particular dispersion phase particles, how this dispersion phase particles are going to move in dispersion medium. So according to this Brownian movement, the bombardment of the particle, bombardment means they will collide each other, the particles will collide each other. Say if we have this collide dispersion phase, these particles may bombarding each other, that means they can collide each other and they may change in their direction like this. There is no proper direction, and this movement is completely depends on the density and the size of the particle. In motion, they collide with the walls and other particles and changes in their direction and the velocity. When the dispersion particles are bombarding with each other with the wall of the particular sample, and they will be collides with each other and they will change in their direction and their velocity also. According to Brownian motion, the particles always move against the gravitational force due to low density. Yes. So just now we discussed the Brownian motion depends on the density of the dispersion phase. When we have a lower density particle, they will be travels or moves against the gravitational force. The particles which have low density and which can undergoes bombarding each other can follows the Brownian motion. So the particle will be getting bombarding with each other and they will follow the Brownian motion. This happens when the particle has low density. Bombarding means the continuous attacking of a particle with their surrounding particles and changes in the direction and the velocity. This phenomenon is known as bombarding. There will be two main reasons to happen this Brownian movement, that is low density of the particles and bombarding. So these will be the two different reasons, and we can calculate the Brownian movement by using this formula, that is D is equals to RT divided by NA by NR, where D indicates the Brownian constant, R indicates gas constant, that is 8.31445988 joules per mole. This is important to remember the gas constant. And Na, that indicates the Avogadro's number. That Avogadro's number is 6.022 into 10 to the power 23. And R indicates the radius of the particle. T indicates the temperature in Kelvin. Temperature in Kelvin, you need to remember this. This is not in the degree Celsius. This explains this Brownian movement will be explains in the temperature. Units are kelvins. To understand the Brownian movement in a simple way, let us take the dispersed particle in dispersion medium. So this particle is, we can consider as dispersion phase particle and which have low density. And then what will happens? This particle will shows this kind of movement. That means this is following the zigzag movement. So if you are observing this entire diagram, this is the starting point of the particular molecule. This is the particle of dispersion phase and this is the end point of the particle. And to observe this movement or motion, you can see in a zigzag movement. This zigzag movement happens because of low density of the particular particle and there is the bombarding of the particle with each other. These are the two main reasons of the Brownian movement. And at the end point, you can see the particle will go somewhere at the end point. So this movement is considered as Brownian movement. Now we'll discuss another theory, that is settling or sedimentation volume, which is also known as Stokes law. So this is also may ask in the exam, explain about the settling theory of the colloidal dispersion system, or they may ask you like write about the sedimentation volume theory, or they may ask you directly explain in brief about the Stokes law. Then you no need to get confused. If they ask any one of these question, the concept is same as we are going to discuss now. So this is also known as Stokes law. This law states that the sedimentation rate V is directly proportional to the radius of the particle and the density differences between the dispersion phase and dispersion medium, and also inversely proportional to the viscosity of dispersion medium. This is a very simple statement, that the sedimentation rate that is V is directly proportional to the radius, first factor radius, and the particles density differences between dispersion phase and dispersion medium, and also inversely proportional to the viscosity of dispersion medium. This is the statement. So this can be calculated by the given equation, that is V is equals to 2r square into rho s minus rho naught divided by 9 eta. In this equation, where the V indicates rate of sedimentation, R indicates radius of the particle, and rho s indicates the density of dispersion phase particle, and rho naught indicates the density of dispersion medium, G indicates that is gravitational force, eta indicates the viscosity of dispersion phase. We have some limitations of this Stokes law, that is, in case of the colloids, the Stokes law is not valid because the colloidal particles of the same mass falls slower than the other due to the size of the particles. Many particles fall faster, due to which they drag finer particles down along with them. Particles should be in spherical shape or regular shape only. To understand this Stokes law, the particles should be in spherical shape or in regular shape only. If the particle is not in a regular shape, by means if the particle is having in irregular shape, then we cannot discuss about the sedimentation volume, that is Stokes law. The particles should not be flocculate, means they should not form some precipitation, or they cannot form some coagulation. The particle should not follow the Brownian movement or Brownian motion. This is important limitation. So this sedimentation volume will not explain about the particles which obeys or which follows the Brownian motion. Now we will discuss another theory, that is diffusion theory, which is also known as Fick's law, also known as spreading theory of colloids. This theory states that the particles diffuses spontaneously from a high concentration region to low concentration region. This theory is known as diffusion theory or Fick's law. Generally, we all know that diffusion means when a solution or any particle from high concentration to low concentration. That means moving from very high concentration, this will be high concentration region. So the movement of the particular substance from high concentration to low concentration, this will be low concentration region, and this is known as diffusion. This concept is also known as Fick's law. Fick's law can be written as rate of diffusion is directly proportional to surface area into concentration difference and thickness of the membrane. Diffusion is a direct result of Brownian motion. Since the particle size of colloids are very small, these can be diffused through membranes easily from high concentration to low concentration. So according to this diffusion theory, the rate of diffusion or the amount of diffusion, by means when a particles are moving from high concentration to low concentration region through a permeable membrane, then that is directly proportional to the rate of diffusion. And to happen this diffusion properly, they will be follow, that means they can follow the Brownian motion, because the size of particles are very small. When we have a very smaller size of the particles, they can cross the permeable membrane easily from high concentration to low concentration region. Rate of diffusion can be written as dA into delta C divided by delta X, where D stands for diffusion coefficient, A stands for surface area, delta C that indicates the change in concentration of dispersion phase and dispersion medium, delta X that indicates the distance covered during the diffusion process. That means how far the distance has been observed during the diffusion process. Diffusion means what again? From high concentration to low concentration. Any substance or any molecule that passes from high concentration region to low concentration region. This is known as diffusion. Example, we can take sugars, salts, acids and bases. These will be best examples for a diffusion process. To understand the diffusion process, let us see with a small example, that here we can take high concentration region. This high concentration is known as donor compartment, and from this high concentration the molecule should be passes through this permeable membrane to low concentration region. It's very clear as it is, from high concentration to low concentration through a permeable membrane. This is what is known as diffusion theory. And this low concentration region is also known as receptor compartment. Based on this concept, based on the diffusion concept of colloids, these will be divided into majorly two types: crystalloids and crystalloidal substances. So the crystalloids means these are the colloids which diffuses very fast and they contains crystal-like structure. These are known as crystalloids. Examples: sugars, salt particles. And coming to the crystalloidal substances, these are the substances, or these are the colloids which diffuses slowly comparatively with the crystalloids. Very simple concept. Here as we discussed, diffusion means from high concentration to low concentration through a permeable membrane. So in this process, the colloidal particles showing two different properties. Those properties are crystalloids and colloidal substances. What is crystalloids here? These are the colloids which diffuses very fast, by means from high concentration to low concentration they will be diffuses fastly, very fastly. This kind of substances are considered as crystalloids. Examples: sugar and salt. Why sugar and salts only? Because when you are trying to add a cup of salt or sugar in a glass of water and you just shake it out, like, or you can just stir it, then within seconds the complete sugar will dissolves in the water, and that phenomenon is known as crystalloid. And coming to the colloidal substance, these are very slow diffuses. That means they cannot diffuses as simple as that of the crystalloids, because they require some time. This type of substance is known as colloidal substances. Example, gelatin, albumin. So when we are trying to add this gelatin or albumin to a water or to any other substance, and we are trying to mix it out, then what will happen? That won't happen. Of course, that will take some time. That type of substance is known as colloidal substances. This can be influenced by gravitational force applicable for the particle size more than 0.5 micrometers. Colloidal particles have Brownian motion and they don't sediment. Applications: molecular weight estimation to estimate the molecular weight, and to study the micellar properties of the drug. These are the applications of the theories of the colloidal particles. Thank you. Hope you are understood.
Like, share and subscribe. Hit the bell icon for more updates.